It gives me great delight, actually, to introduce James. James has been one of the most fantastic supporters of Agile on the Beach ever since the beginning, and it really just gives me great delight to welcome you on stage to deliver the final keynote for 2017. Thank you.
Thank you. I have the whole stage to myself.
Back over with it,
Back, yeah. And I'm going to be talking about, you'll be pleased to know, no doubt, after my trailer for it yesterday about microservices. Is that all right with everyone? Yeah. Nah, I'm not, don't worry. I thought I'd sort of do something a bit different. I am mostly known for microservices, but I thought I'd do something a bit different today. So this is the actual title of this talk. From the Bazaar to the Bizarre, a note on the future of software. I can't promise it'll be useful. I can't promise it's actionable, other than at the end where there's a bit of a call to arms. But hopefully it'll be interesting, and it's a look at some of the things that I find fascinating, both in the sort of deep history of software development, sort of more recent history of software, and where we might be going in the future. And actually, in the pretty near future, terrifyingly enough. So does that sounds okay, right? Yeah. I promise there's not much C code. Not much. Okay, so I'm going to start off with the Bazaar, or Bazaar. Does anyone can guess where this reference might come from? So we had one over here? Cathedral. Eric Raymond. We shall have to see. Maybe I'll ask a different question of you. Where does good software come from? What makes good software? Good programmers. Good, great answer down here. Got Steve down here. You. Yeah. I kind of think of you, Steve, as just the guy who, it's like the mechanic thing. You're not actually making the wheels. You're maybe, I don't know, making them, tuning them a bit. Where does good software come from? Well, my assertion, I'll back this up with some historical information in a moment. My assertion is that it does come from programmers, and it comes from a very specific type of programmer facing a very specific type of problem. Next question, there's going to be some audience participation. You might have noticed this. Does anyone know who these two reprobates are? That's a PDP 11, that is, if that helps date it. Any hands up at the back? Can't see any. So this is 1969, and this is two people who hopefully you've heard of, Ken Thompson and Dennis Ritchie. So these are the inventors of Unix, the Unix operating system. It's kind of an interesting period in history when Unix was invented, because it was essentially a closed source project initially at Bell Labs, started by Ken Thompson, because he basically wanted to play Space Invaders. Right, so he'd been using an early version of, I guess, Unix, one of the precursors, Multics, which was a multi-user operating system. And Bell decided that they were going to move towards more of the batch-oriented operating system. So rather than have multiple users able to log in and access and use resources on the system at once, they would move towards this idea of having like batch processes, which became quite popular. Now, Ken wasn't that happy with this idea, Ken Thompson. He quite liked the idea of having this interactive, multi-user thing. So he decided to sit down and do what most people would think of in that situation, which is write his own operating system, which became known as Unix. Initially, him and Dennis Ritchie wrote this in assembler. So this is 1969. It was then ported to another programming language. This is the only C code in this. It was ported to C, but in order to port it to C, Dennis Ritchie first wrote C, which is another entertaining entertaining thing. There's a great quote from a brilliant blog entry. I think it's called A Brief and Almost Certainly Incomplete History of Programming Languages, where the description of C, how C came to be about, was that Dennis Ritchie, not satisfied with creating a gun that could fire both forwards and backwards, decided to write Unix in C. That's a true thing, apparently. But yeah, it was originally written in assembler, and then Dennis Ritchie created C, basically by adding data types and a few other things to B, the language before it. It's like naming things in computer science, right? When you're just not very good at it. Just call it A, B, C. What happens when we get to Z? I guess we get ZA, and then etc. So these are, two of the most, I guess, important things that have happened in computing in, well, any decade. Unix is now the basis for most of the computers that run the internet, never mind the web, but the internet, the thing that the web runs on. C itself has been described as a virus, right? Very, very simple life form, very, very simple programming language. That is everywhere, systems programming language. And both of these, crucially, at one point were essentially became open source. They escaped the confines of the organizations that created them, in which case, these cases, at Bell Labs. My background, you've probably come across the concept of T-shaped people. I believe there was a talk that I missed about T-shaped and why that can be awkward. Frankenstein, no, it wasn't. It was Jekyll and Hyde, was it? I'm not sure. Anyone go to that? I'm kind of T-shaped, but I guess the depth I have is in Java. So I've got some examples from the Java world, because if we fast forward on from Unix and C, post the Unix wars, post the Free Software Foundation being started, we start to get to the sort of birth of Java, the programming language, and then the explosion of Java, which corresponded with the growth of the internet and the growth of the web. And much like Unix initially, much like C initially, Java was controlled by Sun Microsystems. Diana's nodding, so I'm kind of okay at the moment.
I did the retrospective for the Java 2E project.
Oh, awesome. Awesome, look at that. Right. Right, awesome. So Java came out from this big organization, Sun, which was obviously subsumed years later by Oracle. And partly as a reaction to the JEE project at Sun with Java, a bunch of people got together, including some people like Rod Johnson, Jürgen Höhler, a few others, some friends of mine, Arian Putzmer, and they created an open source alternative to the Java Enterprise Edition set of libraries, and that was called Spring. The Spring project was created. And it was, again, this is sort of a bunch of programmers we talked about who were faced with an issue, in this case, the fact that I'm afraid J2E, or certainly J2E, but JEE as well, kind of sucked. Does anyone program with message beans, session beans, stateless session beans, sessionful stateless messaging beans? Yeah, some people. Yeah. Have you still got the scars? Yeah, there's nods. Yeah, so Spring became a thing. Spring was founded as a reaction to JEE. And there's another, maybe little known, actually skipping backwards in time a bit, little known, but also widely used, massively popular Unix application, which I think is still in most distros actually, which became probably the first true open source project at scale as an experiment. It was run that way as an experiment by its creator, who was Eric Raymond. I think someone mentioned his name already. And this was FetchMail. And this is one of the sort of first true open source in the sense of it was driven by a community with someone guiding progress, who was the creator of this. So you've got this sort of, and why did Eric Raymond create this? Well, it was a response to a problem he was having with the current set of libraries in Unix. I know Dan and I went through some stuff about continuous delivery and where that came from. We talked about ThoughtWorks yesterday. So the next thing I'll call out is something called cruise control. So cruise control is decades old now. And it was the first continuous integration server. And that was produced by people who worked at ThoughtWorks at the time, Matt Femmel and a few others. And Jez Humble was on various teams with these people, Dan North, Sam Newman, these sorts of people. And faced with an issue which was we've got multiple teams all over the world, all working on the same code base, how do we stop each of these teams blocking the other teams from writing code when time zones shift, when the sun goes down? And cruise control was a reaction to that, scratching an itch, right? The problem of that people had, I need to be able to write more code, we need to be able to integrate more frequently, maybe we can automate that. I put this in because often Steve Freeman and or Nat Price are in the room when I do this talk, or have done previously. So JMock, I like to think that JMock was also a reaction to some of the Java libraries, essentially, specifically how difficult it was to use the servlet spec, and mocking out, or stubbing out rather, the servlet spec, all like 300 methods of the servlet request and response libraries. But another, this is another example of a library piece of software that was created by just two people who were scratching an itch, two people who were faced with an issue that they had that they wanted to solve, and open sourced. And famously then, I guess everyone knows what this is. I'm hoping. Are there people in the room who just went to the business track? And if so, I can explain, but being mean. I don't mean to be mean. By the way, there should be no thing, like business should not be a thing. Everything should just be the same thing, just as an aside, right? There should be no business, there should be no IT. We should have business and architecture isomorphism. They should be the same shape. So Linux, famously. So Linux came out, 1991, I believe. That was when Linux was launched initially. Got nods, good. That agrees with my notes. So the timeline runs basically, so 69, birth of Unix. You've got 71 was C. The 80s were the Unix wars, with even Microsoft getting involved. You then got Linux being announced in 91, actually. You've then got Free Software Foundation GNU Manifesto. You've got the first BSD release. This is where, slightly earlier, 77, this is where there was a fork of the Unix project, and so on. And really around, I guess, the sort of early 90s was where open source as a sort of programming technique really took off. And someone mentions The Cathedral and the Bazaar, which is, of course, where the title of this talk comes from. The Cathedral and the Bazaar is a very famous book. It actually contains some pretty deep insights into software development, software delivery. Has anyone in the audience actually read this? Got a copy of this? Yeah, actually there is a few. That's really awesome. It's funny because over time, this the people who've sort of heard of this or read this book has decreased when I've asked people. It's a bit like, I'll try the experiment here actually. Has anyone read Domain-Driven Design? Yeah, a few years ago at conferences like this, everyone would have read it, didn't matter what role you had. It's sort of decreasing over time. But The Cathedral and the Bazaar contains some very interesting insights about why certain styles of software development, in particular why having more eyes on things, or rather the open source model of software development, leads to such popular and very, very useful tools. And there's this great quote, and I've sort of paraphrased it already, but every good work of software starts by scratching a developer's personal itch. This was true for Unix. In that case, the itch was I want to play Space Invaders and I can't. Okay, maybe not. But it's true for the others. It's true for Spring, it's true for FetchMail, it's true for JMock, it's true for Cruise Control. And these are all pretty important pieces of software. It's true for Linux. Another really interesting insight from this book about why open source software development is a good thing, or why it works so well, is this observation. And it turns out, with the open source model, all bugs become shallow. And he uses this phrase shallow, he uses this word shallow in a very particular sense. So it doesn't mean that all bugs become simple, right? The more people you add to a project, or you add to an open source project. What he means is, by this, is that even though you're going to have some simple defects or simple bugs, you can have some very complicated defects. The more eyes you have on a piece of software, the more likely you are to find someone who's able to pick things up and fix them. Something that's complicated to me or difficult to fix for me might be really easy to fix for Steve. Something that's really difficult to fix for Steve might be really easy for me, because we think differently, we're different people. So all bugs are shallow. Just about the same time, around the same time, there was another paper written, which was called This is Worse, Better, which was followed up later by another one, or is better, worse, and then there were others, is better, yeah, it goes on recursively. So this was written by a guy called Richard Gabriel about the differences in methodology between two different schools of software development decades ago. So there was the sort of MIT school of software development who valued formalism, correctness of design, and completeness in design. And then there was another group of developers characterized by the sort of early Unix pioneers and the early open source pioneers who had a different approach, different way of thinking about design. And the title in this case is, because the MIT folk were saying, oh, you can't do this incremental, simple development, use a simple development process, simple design process, which was the Unix approach, because that will make worse software. It won't be bug-free. Now, we need to have formal correctness because that's going to be better. So the title of the paper refers to, is the worse thing better than the better thing, or is the better thing worse than the... Yeah, it goes all a bit mad. So is worse better? So that's a brief trawl through the early years of open source and Unix programming and so on. I don't know how many of you have ever come across me before. I should probably explain I work for a consultancy called ThoughtWorks. And ThoughtWorks, we've been around, I guess, over 25 years now. There's like 5,000 of us globally or something. And in an effort to essentially scale how we share knowledge, about 10 years ago, we created something called the ThoughtWorks Technology Radar. Has anyone come across that? Hands up. Yay, some people have. Cool. So what the ThoughtWorks Technology Radar is an attempt for us to codify the things that our development teams are doing around the world and put them in one place, put these things in one place, so we can share it internally. It then was gotten hold of by one of our salespeople, shown to a client, and suddenly it became a public thing. Our CTO was not particularly best pleased, but over time it's become a very useful tool for us to communicate to the outside world what our teams are doing internally and the sort of things we find valuable as an organization. And given ThoughtWorks as a consultancy, we tend to be asked to solve fairly difficult problems. We tend to be more at the cutting edge of software delivery than many, certainly much larger organizations. And in the ThoughtWorks Technology Radar, I've been a member of that group for about 10 years. What we do is we get together, about 25 of us. It's the sort of heads of tech from around the world. It's a bunch of different experts. So it's people like Martin Fowler. It's people like Neil Ford. I guess you could say industry luminaries. And we try and harvest as much from our teams as we can and then produce this document called the Technology Radar. I haven't been on it forever. This is us. I'm in there somewhere. Martin, yay. Martin, he doesn't like traveling, so, yeah. Anyway, I've been very lucky because I've been on this group. I've been able to spend some time with this group for a number of years, which means I've got a pretty good insight into the direction of travel over the last 10 years in terms of open source and other tooling and trends within the industry. Because what we do is we get about 300 or so new items every 6 months, and we go through a process where we try and we eliminate some of them. We end up with 100 or so newish things that go on the radar. And we end up harvesting a number of themes from the radar. So each 6 months we'll have, I don't know, 4 or 5 themes that sort of we've extracted from the data. And because I work at ThoughtWorks, I get access to all the past data. And so what I've done for your delectation and delight is I've put them on a timeline, which you will in no way be able to read. Yeah. So this is all the themes over the last 7 or so years. I'm not going to talk about every single one. Well, I could, but then we'd end up missing the boat this evening. But I'm going to call out a few things as we talk through some of the trends in our industry over the last few years. And then I'll move on to the future. So the first thing is, we're quite proud of our ability in ThoughtWorks to pick things that turn into a thing for the rest of the industry. We're pretty on point normally, usually, with our observations, with the tools that we're using, and the stuff that gets on our radar. And yeah, I don't think it's too far of a stretch to say we actually help shape, in a lot of ways, the direction of the industry using this and also with the people who work for us. But that's not always the case, so I'm going to call out two weird things initially. So the first thing I'm going to call out is back in, where was it? Is this working? Oh, that didn't work very well. Look. Shiny. It doesn't work when I'm presenter mode. That sucks. Back over here. There you go. Look at that. Google Wave appeared. Now, who remembers Google Wave? Yeah. Where did Google Wave go? This was the future of communication, right? This is how everyone was going to communicate in the future. And we thought back in 2010 it was going to be the future. You didn't really see it much again. Also, a very strange thing happened, and I won't use my fancy clicker. Maybe I will. Can I try it? There you go. No. Mobile. Apparently, ThoughtWorks only thought late 2012 that mobile was a thing. We should assess mobile, he said. I think there was another one about UX. We should assess user experience in about 2011. I think it had been a thing for a while. So we don't always get things right, but there are some interesting trends. So the first one I'm going to call out is specifically because of a conversation I had last night in the after party, as it were, with Steve. So Clojure and related tools. This is So Clojure is a functional programming language. It's a Lisp. It was created by a guy called Rich Hickey some years ago. And what I'm going to show you is where we started talking about this on the radar, and I'll talk about other things that are probably more relevant. So as an example, we started talking about Clojure in 2010 with Clojure and Scala. Also, we started talking about things like polyglot development, right? This is when we started saying most developers now need to be not just able to write or use one language, but also be able to switch between languages, right? Sometimes many of them. And then we move up a bit, and we've got things like JVM as a platform, so moving away from just adopting Java, but adopting JVM and the languages that run on top of it as a platform in your organization. And then we've got things like, in 2012, we've got increasing diversification in browser-based languages, so this is things like ClojureScript and so on. The interesting thing with Clojure is if we then plot the actual items on the radar, not the tools related to them, to this, not the themes rather, we don't actually have that much. So what this is saying is we said assess Clojure in your organization back here, trial it in 2012, and then in 2014, right, adopt this. This is ready for the mainstream. Given the right set of problems, we should probably think about using Clojure. Mason's Razor, the head of tech in North America, Mike Mason, Mason's Razor says he would laugh at you in the pub if, given the right set of problems, you weren't using Clojure. That's an alternate definition of adopt. But actually, there's not much activity happening in the community. I mean, there is a lot of activity happening in the Clojure community, but the impact that we're seeing in organizations, enterprises that our teams are in, is not so much. So a few items. Okay. The next thing we're going to talk about is Node and JavaScript. So we first started talking about JavaScript and Node way back when, right? So JavaScript as a first-class language. We started calling this out because what we were seeing in big organizations was, or actually in most software teams, was that people were writing reams and reams of JavaScript as single-page applications became more popular, but not treating that JavaScript as if it was real code, by which I mean writing it test first, writing any tests at all, refactoring it, doing this kind of thing. And this is, I think, still a problem now. And I always used to laugh because, back in the day when I started Java programming, we used to write Swing code, right? So we create thick clients in Swing, and they would talk to a server backend via a socket of some description or via a socket. And there was a whole industry in terms of how do we correctly test components in Swing? How do we acceptance test components in swing. And of course, this is what we're doing now with single-page applications. We're doing exactly the same thing again, except forgetting all the things we learned about what we should be doing with things like thick clients. How do we acceptance test them in the browser? How do we refactor the domain code? I think it's getting better. We're still not there. We also have things, again, increasing diversification and rigor in browser-based languages, treat all code with respect on the testing theme. But then we start to get into the JavaScript juggernaut rolls on. And then churn in the JavaScript world, followed by, I quite like this one, JavaScript tooling settles to merely chaotic. There's a quote from Prague Dave Thomas. It was on, which I quite liked, which was, I don't know what my favorite JavaScript MVC library is this morning because I haven't checked Twitter yet. Quite like. And you can kind of see this in the data. So we first put Node.js on in Assess in 2011, and then Trial 2013, and Adopt in 2014. But you get this massive explosion of libraries. When we all get together every 6 months and we're sitting around the table and someone sort of says, insert noun.js, and you have to explain what it is. And as soon as you hear the .js, there are groans. Oh, God, it's another build tool for JavaScript. Who programs in JavaScript? There's quite a few, yeah. This might be a bit niche for this crowd, but I'll introduce the idea, and maybe on the boat later we can play. Right? There is a drinking game you can play, which is called the NPM install drinking game. And this is where, and I've done this before, we're not going to do it, so but whilst respecting the code of conduct of the conference, you ask the audience to call out a noun, and then if you can NPM, which is the package manager for JavaScript, if you can install that noun, you don't get a drink. So the idea is you have to find a word that isn't a JavaScript library, and it's vanishingly rare that you can actually do it. This is true, the NPM drinking. There's also an evolution of this called NPM Call My Bluff, if you've ever seen that television show, where you have 3 alternate descriptions of a JavaScript library, and you have to work out which is the right one. Anyway, churn in the JavaScript world. So yeah. And as you can see, there was this huge explosion, and it's still continuing, although it is settling a little. Mean time to microservice mention, now, for those of you setting your clocks. So interestingly, we didn't really name microservices as a thing up until, explicitly as a theme, until about 2014, early 2014. But if you think about, well, what my idea of microservices are, which are things, componentization via services, it's things like built around business capabilities, infrastructure automation, designing for failure, all these interrelated concepts that led to microservices. You can see where a lot of the thinking came from, because we've got themes for a lot of this. So we've got things like continuous delivery, evolutionary architecture, evolutionary design, build pipelines in 2010. Moving on, again, we've re-blipped it with polyglot development. So one of the key things with microservices, you break things up. You can, if you want, implement them in different languages. Simple techniques for performance testing, focus on CD and tools, smaller, simpler, faster applications and services, simple architectures, Conway's law, all these sorts of things start appearing before microservices. But then when microservices does appear, which is, as I say, sort of 2012 in Assess, and then Trial later in that year, we again get this massive explosion in tooling, techniques, products related to building microservice architectures. Until finally in 2000 and, where are we? Let me go back one. Finally, late last year, we talked about microservices as programming model itself. And this is related to the paradigm shift that we were talking about with Dan last night. So this is where actually we're changing, this technique forces you to change the way you build your applications entirely and forces you to think in a very different way. So that's microservices. I'm going to do one more. I think you're probably all bored with this by now, right? Containers. So containers only appeared sort of radar, as it were, around, well, related to containers, things like reproducible environments, using things like Vagrant to have local development environments. Sort of here in late 2012, so related to developers writing code on the same operating system that they're going to be deploying code to, things like Phoenix environments. And then as we go further up, we've got explosive growth in the Docker arena. We've got, what's the next one? Docker incites container explosion, which is, I think Martin Fowler was particularly pleased with with that sentence. And then Docker, 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 which is where the Docker, Docker, Docker joke comes from. Not really a joke. And then microservices as programming model, using Docker as the underlying platform. You've got developer experience. You've got rise of the platforms. So again, we've got, and this will probably continue now, but we've got this explosion in technologies related to this. As people pick up on this idea, see that it's useful, start using these sorts of tools, these sort of techniques, and then find new itches and start scratching them. And then, of course, the big companies get involved, right? Then, of course, you get API gateways you can buy. You get all this other stuff related to it. You can buy a Docker farm or something, I don't know, whatever you can buy these days. You can have multiple implementations of private platforms as a service. And you get golf clubs with them for free, which is nice. But again, these sort of explosions are generally in relation to software developers, programmers, people involved in technology scratching an itch. So the final one I'm going to call out, specifically related to big companies and open source, is this, a new wave of openness at Microsoft. Are there .NET people in the room? Any .NET devs? Yeah. Awesome. A new wave of openness at Microsoft. So this is when Microsoft changed direction and started open sourcing a lot of the platforms that they're building software on, things like Visual Studio, you've got .NET Core, you've got Mono, all this sort of stuff, which marked a really radical change of direction. Sort of in the same way that there was like a Unix leaked out of Bell in some senses. We also have this developer experience as a differentiator. So you've got, it's not just Microsoft who are doing this now, not just Microsoft releasing open source software, everything's on GitHub. Actually, if you look at the UK government, most UK gov code, gov.uk code is on GitHub as well, it's all open source. But then there's a ton of other companies. I'm sure people are using tooling from some of these as well, right? So we've got like the Netflix open source stack. We've got things like Cassandra. We've got all the stuff, Apache Kafka, which came from LinkedIn. All this stuff that's been open sourced and you can use for free, which is, I think, awesome. It also provides some challenges, though. So at ThoughtWorks, we're pretty committed to building as diverse an organization as we possibly can. So over the years, we've had to change our hiring policies. Or not policies, that's the wrong phrase. We've had to change where we look for people to hire, right? If you're going to try and create a diverse organization, right, you can't just look in the usual places for hiring people. You have to go to different places. So you don't just, for example, look at computer science graduates. You don't just look at physics graduates. Because I did physics, and on my physics course, I think there were, I don't know, it was probably about 50 people, maybe less, 40 people, 2 of whom were female. Right? It's very, very similar in the other sciences, and certainly in computer science, although it's changing. So you have to look at things like STEM, right? You have to look at widen the net so that it's not people who go into university who you're looking at hiring. And then invest in training and et cetera, et cetera. But one of the issues with this, and I think it's quite subtle and quite pernicious, and there's been quite a lot of talk about this recently, is the kind of programmer culture and how toxic it is, especially in startups, with respect to encouraging diversity. And actually, when these companies are open sourcing their software and it's all going onto GitHub and so on, they're actually using this as a marketing tool to attract talent, as well as doing this for the benefit of all. But the problem is, if you only attract talent from the people who are working in these communities, places like GitHub, you end up attracting people who look like the people who are already there. So I'm just going to make a comment about this and be careful of this kind of rebuilding or encouraging this programmer culture by only hiring from very particular places. like GitHub. So, right, lifting the mood a bit now. I'm a massive science fiction fan. So that's where we've been going as an industry, over the last sort of decade, and then before that into deep time. So what about where we're going next? So from the Bazaar to the Bizarre. I'm also in ThoughtWorks part of the group that looks at sort of H1, H2, H3 horizons in terms of where we want to build capability to service our clients in the future. And to do that, we use something internally called our technology strategy, which calls out trends that we think are interesting, trends that we think are worth us as an organization placing bets on to upskill people, to grow new skills, either for the next 18 months, for the next 2 to 3 years, or 3 years plus. So I'm going to go through a little bit about what ThoughtWorks is looking at in the near future. And this is actually a thing. So the first thing I'm going to call out is this idea of humanity augmented. This is something that we've got on our internal stuff around technology strategy. So what we mean by humanity augmented is the changes that we're going to be seeing in the really close future around things like AR, around VR, that's happening already, but also around things like embedding stuff in people. There are people walking around New York, some of my colleagues, with chips in them at the moment. Kind of strange. So things like voice as interface. How many have got an Alexa at home? Cool. You have turned off automatic ordering confirmation, right? Good. Because otherwise, there's this lovely cartoon from XKCD, and the cartoon is the guy walking in. He says, Alexa, order me a ton of cream corn. Alexa, confirm purchase. And the sort of subtitle is, I always like to know if someone else is listening when I visit a friend's house. I quite like that as an idea. I'm not suggesting you try that, right? That would be wrong advice, bad advice. But things like, we've also got on this autonomous corporations that run themselves. I'll give you an example of some madness, but real madness. I was at a conference in Iceland a couple of years ago talking with the creators of EVE Online, they're called CCP games. And EVE Online is this massively multiplayer, space-based game. And we were talking about VR and how they were going to start using VR. And their head of production and head of game design, not as in UX, but as in world design within the game, they'd just been to France to meet some researchers to look at latest developments with VR and AR. And the first one, this is working. So apparently you had to go into this room, and it was like a closed room with, if you've been to an optician's, you put your head in a little thing, and you kind of look at it, he said, right, I'm going to warn you, I'm going to count down from 3, and when I get to 0, I'm going to turn this on, because it's a bit weird. And so it's a thing called direct retinal projection, right, if you've come across this idea. So this is where you scan a laser directly onto the retina. There is no screen, so therefore there is no pixel density to take care of. It's just a laser scanning on your retina. And he said, okay, 3, 2, 1. And he turned it on. And the guy said to me, and there was a fucking dinosaur in the room, right? Literally, like, indistinguishable from real life. That's happening now. It's in research at the moment. There are some issues around stabilization of things, but it's happening now. And he said within 10 years, the same researchers, they've got already working direct stimulation of the optic nerve in mice via electrodes. Hackable eyes. Yes. Internet of Things security starts to be a bit more important when people can hack your eyes. All right. The next thing we've got, following on from dinosaurs and being able to hack your own eye or someone else's eyes comes up there. Security, privacy, transparency. And some of the things we call out here are, again, obviously all the kids on here are, what's the phrase, well woke. And so on-chain, I think that's where's my blockchain expert? He's sitting at the front. Yeah, is that the right thing? Yeah, all right. But things like, autonomous corporations run off blockchains, run off smart contracts on blockchains are a thing. I mentioned I'm a huge science fiction fan. There's a British author called Charles Stross. He wrote this book called Accelerando, which is essentially about humanity's journey through the technological singularity. It's like a series of short stories as this family goes through this huge period of technological change. And in this, he describes something called economics 2.0. And it's basically communism, automated communism. There was someone here that had a great quote. I don't know where you are. There was a great quote that he had, which is that communism is a perfect system apart from the humans. Right? You put humans into communism, it doesn't work anymore. In this book, the description is of communism but run by essentially machines, right? Computers running all of the economy all the time, with no human integration. And there's this great passage where he talks about the main character and how he's being sued by, by his ex-wife, as it turns out, for some money, and all the money is locked up in a set of companies. And in this passage, he replies to the lawyer who's trying to get hold of the owners of these companies with this, which is meaningless. The president of DNS name is DNS name. The secretary of is etc. And the chair is DNS name. So the idea that actually directors of organizations no longer are human beings, but they're web addresses. Right? Interesting, like DNS names. Essentially smart contracts. Now, if you think about what you could do if this were the case, and you put an API on Companies House. I talked internally with our lawyers about this, and this is feasible without rate limiting. If you put an API on Companies House, for those of you who don't know that, that's where you can go to get information about any registered company in the United Kingdom. You could, in theory, register companies faster than you could dereference the owners of those companies, right? You could create more companies more quickly than you could actually follow the chain, which would effectively make you totally immune from litigation. Right? If you could never find out who owned something because there was a never-ending chain, our legal people weren't. They were like, what? I wanted to use it in a training course, actually. I thought it'd be a really cool training exercise. You know, write some code like RESTful service, talking to a RESTful service, like microservices stuff, and this was the exercise. And they told me I wasn't allowed. So. And there's a funny thing down the bottom. You know, all these regulations are written in Python. This already exists. This is essentially what smart contracts are on chain. Get woke, kids. You've also got things like quantum computing, right? Quantum computing, that's something that we're starting to look at. Google have made a huge investment in quantum computing. They're due to announce a breakthrough pretty soon, allegedly. Been writing papers at a rate of knots. Rise of the robots. That's on our radar next. And if you haven't seen in the news recently, many of the big organizations out there, so Google, Facebook, have joined this thing called the Partnership on AI in order to try and forestall the inevitable demise of humankind, essentially, as we are superseded by the robots. Partnership on AI. Another thing that we're looking at how we can, and this is H3, so it's a bit further out, but it's nanotechnology. So the Nobel Prize in Chemistry went to people making nanomachines last year. I think it was 2016 Nobel Prize in Chemistry. That's a thing. Grey goo could actually happen. It's on the horizon, allegedly. Kind of interesting. So my assertion is we are already essentially living in the future. We already pretty much have tricorders in our phones, right? But to quote, oh God, totally forgotten his name. Doesn't matter. It's just not evenly distributed. So I'm going to go a bit further out now and look at not just what ThoughtWorks are interested in, but some of the crazier stuff that's happening. We're going to play a little game in a moment. All right. So does anyone recognize who this guy is? Well, probably says on it, doesn't it? Did anyone read this article? Anyone come across this? It's kind of interesting. Yeah, it's in one of the sister publications of The Economist, and it basically says if you want to know why Elon Musk does the things, and also what's his name, Facebook guy, does the thing or doing the things that they're doing, right? These are the books you should read, right? Because many of the ideas that they've got come from these books, and they explicitly call out Ian M. Banks, who is a British author who wrote a series of science fiction novels set in something called The Culture. And essentially what I think this guy behind me, not that I don't know the guy, I think essentially what they're worried about, what he's worried about, is that we are approaching some kind of weird place where innovation is going to start overtaking our ability to cope with it. And I mentioned singularity earlier in relation to Charlie Stross. Now, the earliest mention I could find of the phrase singularity was actually in a conversation between these three folks. I'm not sure if you could recognize any of these guys. So this is a mathematician, a very famous mathematician called Stanislaw Ulam, who was jointly responsible for, amongst other things, Monte Carlo simulations with one of the other guys up there, John von Neumann, and Richard Feynman. And this is from Los Alamos. And actually, the initial usage of the word singularity was by John von Neumann, apparently. So ever-accelerating progress of technology and changes in the mode of human life, which gives the appearance of approaching some essential singularity in the history of the race, beyond which human affairs as we know them could not continue. This is his prediction back in 58 to Ulam. This is the earliest I could see this being mentioned. There's a lovely passage back again in Accelerando, which starts with the lovely phrase, "Welcome to the early 21st century, human." Set about 20 years from now. Around the world, labouring women produce 45,000 babies a day, representing 1,023 MIPS of processing power. Also around the world, fab lines churn out 30 million microprocessors a day, representing 10 to the 23 MIPS. In another 10 months, most of the MIPS being added to the solar system will be machine-hosted for the first time. Quite a strange idea. Quite soon that's going to happen. So, we're going to play this game now. Do we want to shout, or do we want to... We'll see how it goes. We're agile. I can change. Maybe we'll start with shouting. If it doesn't work, we'll go hands. Then we can do standing up. Yeah, how fascinating. Right, so my first fact for you. Science fact or science fiction. 2045, automotive automation, 100% penetration in global north. Fully autonomous, self-drive, fully autonomous cars, 100% penetration global north. Science fact or science fiction? Fact. Fiction. Okay, hands up. It's not going to work, is it? Hands up for fact. Hands up for fiction. Okay, right. So it's about even, actually. So this is some research. I mean, I can't actually. I'm going to caveat this, right? But I can't say it's a fact or fiction. It's based on analysis of data and prediction of that data. So it's predictive, right? So in this case, it would be fact. So this is from Morgan Stanley, and they're talking about 2 decades time, 100% automation of automotive water. You just read the slide. Pretty crazy. And, you know, Morgan Stanley, though, they're normally in business circles, they normally are thought of as fairly flaky, you know, not to be trusted. Well, I mean, amongst certain groups, but yeah, interesting. So, and this represents tremendous change in society. That's what that quote is about. That's from a Medium article talking about the number of unemployed truckers just in the US, not the supporting industries. It's talking about towns that will disappear because they only exist at the moment to provide support services for truckers, in the same way that towns disappeared when the railroads arrived. So 2045, fact. Next one, 2070. So when I'm about 90 years old, there will be 1 million people living on Mars. Hands up, fact. Hands up, fiction. Both hands up, terrified. Yeah, this is a pretty crazy one, actually. So, I mean, this is extrapolating from best possible case from Musk and his BFR project, SpaceX and the BFR project. And if you've come across BFR, if you don't like swearing, just sort of go la 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 la. It stands for big fucking rocket, right? This is actually what it stands for. And it's in the process of being built, right? The BFR is in the process of being built at SpaceX. The idea is that Musk is going to start in 2018, which is the next time Mars is at its closest approach to Earth. The first mission is going to go to start sending materials to Mars, right? Then every 2 years, with an exponential growth in the number of missions going every 2 years. So every closest approach, there's going to be more and more rockets going before eventually, in about a decade's time, maybe less than that. When did he say recently? Well, whatever it is, the first humans are going. We're already testing the capsule that's going to keep people alive. He's got a real plan to create a city on Mars. And the numbers, if you look at them, the engineering as in the engineering numbers, aren't that crazy. So this is a real plan by a pretty serious dude, using something called the BFR and reusable rockets to put people on Mars and have 1 million people living there by 2070. Actual thing. Well, he's got a plan. We all know how plans have a habit of working out, but, hey. Fact. Next one. By 2045, your phone will do more calculations per second than all human brains. Fact or fiction? Fact? Fiction. So again, predicting, this is extrapolating data from real data. This is from Wait But Why. So normalizing for compute per $1,000 by 2045, you'll be able to buy, for $1,000, more compute than all human brains. Wow. Fact. Yeah, really fast. There's lots of wait 10, wait 10. Anyway. Next one, right? We're getting to the end now. 2030-ish, companies mining asteroids in moon orbit. Fact? Fiction? No idea. So, I'm nearly done. So this is from another really serious dude. This is Charles Simeone. If you've come across Charles Simeone, the Hungarian who put the Hungarian in Hungarian notation, also father of Excel, Word, and the rest of the Office suite at Microsoft, one of the very early Microsoft employees. I don't know how much he's worth, 5 billion. He went to space once, paid 30 million to go up to the ISS for 10 days. And then because apparently, and I quote, I didn't get a chance to appreciate it the first time, paid another 30 million and went up again. And he's got a company, or he's involved with a company with some of the Google people and James Cameron, called Planetary Resources, Inc. And they have satellites in orbit at the moment, prospecting for near-Earth asteroids with a plan in the next 10 or so years to be mining them in Earth orbit and firing the minerals back at us. Well, towing them gently, I hope. They've had a setback because they lost some of their satellites when one of the SpaceX rockets suffered a rapid disassembly event, as Musk refers to it. So again, fact, right? I can go on, right? So we're building the world's biggest radio telescope. It's going to be able to listen for alien. It's going to be powerful enough to detect I think it's like, the fact is ridiculous. It's like to detect an air traffic control radar at like 200 million light years or something. So we can find aliens. This is why we're building this. It's in Australia and South Africa. Oh, hi. Crazy stuff, crazy stuff, crazy stuff. I mean, my point really is that we're living and we're moving to an even more connected, more automated, more augmented world than ever before. And we're actually, serious organizations are planning for this, and serious people with serious money are making it happen. It's kind of interesting. But I'm going to turn back to where I started, right? Who is going to create this future? And currently it looks like there's some single individuals or big organizations that are driving innovation. But that kind of was happening in the early days of computing before Unix too, or the early days of open source software with things like Java. And, history is a habit of repeating itself. It's cyclical. Back to communism. That's what Marx said. Turns out history is cyclical. And I think that actually open source software is still going to be a driver of revolutionary change in all of this stuff that we're doing. We're still going to have a bunch of people out there who've got itches to scratch. But I think the cathedral is dead, right? The age of building these huge, big systems, big vendors selling them to organizations, I think that's over. I think the age of the Bazaar is definitely here to stay. And all this stuff, crazy stuff, We can build this. We can get involved. You can go now to Amazon and use their image recognition service to do crazy stuff. You can OCR stuff. You can use tooling that you would have had to pay $1 million for only 5 years ago on a pay-as-you-go basis. You can scratch itches where we never even knew we had things to itch. Dug myself out of that hole. But I think it's in your hands, right? It's in our hands. We need to go out there. We need to create. We need to, as developers, as technologists, as people involved in the industry, we need to take the bull by the horns and do this stuff. I'll finish with a quote from the great Alan Kay. The best way to predict the future is to invent it. That's all I got. Thanks.